Hi, welcome to another video of teaching Algebra 1. In this lesson, we're looking at section 1.3 of chapter 1, which is about solving equations that have variables on both sides. In this video, we will learn about solving linear equations that have special cases as well. And we will also learn more complex solving systems of linear equations. In the last video, I taught you how to solve multi-step linear equations. In this video, we're doing about the same. Instead, we're also going to be learning about the distributive property, and we're going to apply the property in solving such linear equations. So let's start with solving equations with variables on both sides. So if we look at question 1, we're given that negative 2x equals 3x plus 10. If we look at this equation, we can see that we have variables on both sides of the equation. Here we have negative 2x and here we have 3x. To solve this equation, we know that we have to bring the variable on one side, and we can do that by using the subtraction property of equality. So if we do minus 3x on this side of the equation, we can do the same on this side of the equation. And if we do that, the 3x and the negative 3x cancel out, and we get negative 5x equals to 10. And then we can just use the division property of equality to get rid of that coefficient of negative 5. So if we divide by negative 5 on each side of the equation, we get that x equals to 10 over negative 5. And this simplifies to negative 2. We're given that negative 10 plus 4x equals 9x. Again, this is a situation in which we have variables on both sides. So on the left side we have 4x, and on the right side we have 9x. So we know that we can use the subtraction property to get rid of the x here, so we can move it to here by adding minus 4x. So if you do negative 4x on each side, the negative 4x and the 4x cancel out, and we're left with negative 10 on the right side of the equation. And then here we're left with 5x. So now we can divide each side of the equation with 5, and if we do that, we get negative 10 over 5 equals 5x over 5. And now we can just cross out that 5 over 5, which leaves us with x equals negative 10 over 5, which simplifies to negative 2. So the key concept here is that we have to make sure that we bring one of the variables to the other side of the equation so that we can simplify the two variables. And then we're only left with a constant on the other hand of the equation, so that we can use the properties of equality to get rid of that coefficient on the x. And then we're just left with only one x. So now that we know how to solve equations with variables on both sides, let's look at some harder linear equations. Some harder linear equations require the knowledge of the distributive property. We've learned that property in middle school, but I'll introduce it to you again. So say you have some variable x or a, and you multiply with x plus y. We can see that the variables x and y are being added in parentheses, and this is being multiplied with the coefficient a. So this property says that if we do this operation, we get a times x, which gives ax, plus the other hand of the equation, which gives a plus y. So this property says that if you have some variable a which multiplies with two other variables being added or subtracted in parentheses, then you get a times x plus a times y. Now here we have this harder equation which uses a distributive property to solve. So here on the left side of the equation, we can recognize that we have 0.5 times 6h minus 4, which is in distributive form. So we can apply the distributive property by multiplying 0.5 with 6h, which gives us 3h. And then we could do the same with the second term in the parentheses. So negative 4 times 0.5 gives us negative 2. And then we equal that to the right side of the equation. Now all we have to do is switch the variables and the constants so that we have variables on one side and the numbers on the other side. And then we can use the properties of equality to solve the equation. So here I can see that we could subtract 3h from each side. And at the same time we could subtract negative 1 from each side. So this cancels out, so we're left with only constants on the left side of the equation. And here we cancel out this constant. So we're left with only variables on this side of the equation, which results in negative 3 equals negative 8h. And then we can simplify this by dividing by negative 8 on each side. And if we do that, we get h equals negative 3 over negative 8. So we have used the distributive property in this equation, and we have also used the properties of equality to solve this equation, which gives that h equals 3 over 8. Now this isn't the end of solving linear equations, as we also have some special cases that arrive in solving equations. Instead of just showing you the cases, I will solve some equations which will reveal these cases. So here I have this ordinary looking equation. It looks very simple. We could just like use a distributive property and solve the equation, right? Well, no, it has a special case. So if we apply the distributive property, we get 6 times 5x, which is 30x, plus 6 times 2, which is 12, equals to 30x. And then we can just remove the variable from one side and move it to the other side. And then we just use the division property to get x by its own. But that's not the case. When we subtract 30x from this side to move all the x's to the right side of the equation, we completely eliminate all of the x's on both sides of the equation. And when we do that, we get 12 equals to 0. And this is not true, so there is no solution. And this is a sign for saying there's no solution. So we know that one of the cases is when an equation arrives to no solution. Now let's look at case 2. So here we can see there's a distributive property that should be applied on both sides of the equation. So if we do that, we get 3 times 2a, which is 6a, and then 3 times negative 2, which is negative 6, equals, and then 2 times 3a, which gives us 6a again, and then 2 times negative 3, which is negative 6. Looks fishy, doesn't it? We have 6a minus 6 equals 6a minus 6. So it's the same. We can add 6 on this side and do the same on this side. And if we do that, we arrive to an equal equation again. We have 6a equals 6a. So let's divide each of the sides by the coefficient. And if we do that, we get a equals a, as the 6's cancel out. So here we know that this is a true statement. A does equal to a. Therefore, whatever number you plug in for a, say you plug in 1, you do get 1, because 1 is equal to 1. If you plug in 2 for a, then this a must equal 2 as well. Therefore, 2 equals to 2. Say you also plug in 1 billion or 1 million. If you plug in 1 million for a, you also get 1 million on the other side. Therefore, this equation has infinitely many solutions. So whatever number you pick, it's gonna be a solution to this equation, since a does equal to a. So this is it for section 3 of chapter 1. In the next video, we will talk about solving absolute value equations. We will also talk about solving equations involving 2 absolute values, and also about identifying special solutions of absolute value equations. I'll see you in the next video. Please leave a comment about how I should improve my videos, and if you like my videos, please leave a like. Thanks for watching.